Hello, welcome to Soil Mechanics Lab, whereby we want to do wet sieving. Before you do wet sieving, you need to get a sample, a representative sample that you are going to do the wet sieving. So I have my soil sample on this tray. So I'm going to do what we call a quartering. Quartering is just only dividing the soil sample, whatever soil sample that we have, into 4 quarters like that, and get a representative sample from each quarter. And I'm going to weigh approximately about 100 grams. And this 100 grams has to be collected from the different portions. So here, as you can see, is that I have already a sample which I've done the quartering, and I've already gotten 100 grams. I have to get a measured amount of sample that I'm going to do the wet sieving. So after getting that, then the next thing is that I will have to do the wet sieving and allow the water that is used to clean this soil sample to pass the 75 micron sieve. So I will do the wet sieving until the water that comes out of this sieve is clean. So I'm going to pour the soil sample into this metal karai, which I'm going to use it to do the washing. So I'm going to open the tap so that I allow water to flow. And just below down here, I have the sieve, the 75 micron sieve, which I'm going to place it down there. So when I do the washing, I'm going to pour the water to pass through the sieve so that I'm able to collect my soil sample. So I'm going to decant and allow the water to pass through the sieve like that until the water that comes out is clean. So just do like that. The washing is done until you ensure that the water that comes out, or the water that comes out, is clean as such. When you do that, you will have ensured that the very fine ones will have gone with the water, and whatever remains on the sieve is taken back to what is in that container, so that you put it in the oven. So as you can see, the water that comes out is that it is not the way it was initially when you started the wet sieving. It's more or less clear. So usually the wet sieving, you do it until you find that the water is clear. When that is achieved, then you wash what is in the sieve. So I'm going to wash so that because there is some particles which are bigger than the sieve aperture, which are on the sieve. So I want to ensure that whatever is in the sieve is again mixed with what is on the container. So as I do that, you can see the water which is coming out. Just use a little pressure on it so that you don't damage the sieve. So again, you can see the water that is coming out from that sieve is more or less clear. So when you ensure that you have clean water coming out, then now you can mix your soil sample. So as you can see what we have there, so we mix with this one. This is how we normally do it. So I'm going to decant. So I have my sample inside. So I want to collect my sample. So just slightly. This is how we normally do it. Slowly, slowly. It's going to decant slowly, decant slowly. So I'll just pour the excess water, just slowly like that. Without losing my particles. Just like that. After doing the wet sieving, the next step is to take the soil sample and put it inside the oven. And usually these containers, they normally have a numbering. So for example, this is container number 209. So if I have several samples, I can be able to differentiate one sample from the other one by getting the container number. So usually we have the container numbers. So I'm going to put the sample inside like that, and then I close. After ensuring that it is closed, then I need to put the oven on. So I'm going to switch it on like that. After 24 hours, we now come and remove the soil sample. So I will first of all put the oven off, and then I open, and I have to let the soil sample to cool for about 30 minutes before removing. After 30 minutes, or after cooling, which is a period of, let's say, 30 minutes, you can now come and pick your sample from the oven, and you now come and do the dry sieving. The dry sieving is whereby now we sieve the sample, or we pass the soil sample through a set of sieves. We are going to do that manually, although we also have what we call the mechanical shaker, which can be able to, you can be able to assemble your sieves in that order, starting from the big sizes to the smaller sizes of apertures, and then you pour your soil sample, then you shake. But here we are going to do it manually, whereby we are going to pass the soil sample through each set of sieves and be able to shake and be able to measure the amount of soil sample collected on each sieve. If you look at our tabulation sheet, we have various sizes of sieves. So starting from 2.5, 2, all the way like that, up to the last sieve, which is the number 275 micron. So you are supposed to use those sets of sieves to be able to sieve the soil sample, or to pass the soil sample through those sieves and record the amount of soil sample which is retained on each sieve. I will take my soil sample and pass through each set of sieves. I will have to place the pan. This is what we call the pan. This is the pan, which is going to collect the soil sample that is passing through the particular set of sieve. So I'm going to pour the soil sample through this sieve like that and be able to shake like that. After shaking, I will get the soil sample which is retained on the sieve. So for example, this one, there is none. So this is a sieve number 38. So if you look at on this tabulation sheet, we don't have a soil sample retained on this sieve. So I'm going to indicate that is 0. There is none. So the next sieve is this is sieve number 316. So I'm going to pass again this soil sample. So I'm going to pour the soil sample again on sieve, the next sieve. As you can see, there is some material which has been retained on this sieve. So I'm going to weigh that. So I'm going to pour this. That is 12.8 grams has been retained on the 316 inch sieve. So I'm going to go to the next sieve, which is this is sieve number 7. Again, pour that inside. And again, you can see there is some soil sample which has been retained on that sieve. I need to tear, or that is to have my balance reading 00 before pouring in the soil sample, so that I am only able to get the amount of soil sample which has been retained. This gives me 21.2. Again, on this next sieve, there's a soil sample which has been retained on that. So I'm going to get again the mass of that. Everything that has been retained has to be measured. So you can use a wire brush to be able to ensure that you get everything that has been retained on that sieve measured. That gives me 13.1. That was sieve number 14. So again, you can see there is a soil sample which is being retained on this next sieve. And as you can see from the pan also, we have some material which has passed through this sieve and has been retained on the pan. That gives me 16.9. So we have already sieved up to sieve number 25. So the next step, since we still have soil sample on the pan, which means that it has already passed, we have some soil sample passing sieve number 25, we need to proceed with the other sets of sieves. We still have number 36, we still have number 52, number 100, and then finally number 200, which is 75 micron. When you do all that, you can now be able to come up with the total figure by adding all this and be able to compare with what you had initially. Remember, initially we started with 100.0 grams. So when you have this, you can now be able to add the various weights which have been retained on each sieve and compare with what you had originally. When you sum here your totals and you work out and you find that more than 10% has passed through sieve number 200, then you proceed to the next step whereby you now get the soil sample for hydrometer analysis. So hydrometer analysis is dependent on the amount of soil sample that has passed sieve number 200. If it is greater than 10% of the total what you had initially, then you proceed to the next step. But if it is less than, then now you can now be able to work out the various distribution of those particles and come with that curve without necessarily going to hydrometer analysis.